Now we'll see the bubble sort algorithm. So the bubble sort algorithm sorts the elements of the array in ascending order. Now we scan the array element from left to right, and if the elements are not in ascending order, then we swap them to sort them in ascending order. So every time we scan the array from left to right, we end up sorting the one element in ascending order. Now example we have taken here, 4, 3, 1 and 2 are the array elements. Now first I'll start scanning the array element from left to right. So first element is 4. Now 4, I'll compare it with the adjacent element, that is 3. Since 4 is greater than 3, that means 4 and 3 are not in ascending order. So I swap 4 and 3. Now I compare 4 with the next adjacent element, that is 1. Now since 4 is greater than 1, so they are not in ascending order. So I swap 4 and 1. Now again I'll compare 4 with the next adjacent element, that is 2. Since 4 is greater than 2, they are not in order. So I swap 4 and 2. Now I have reached the end of the array. Now if you see, the largest element, that is 4, is placed in the appropriate position. That is the last position in the sorted array. So since at each scan we end up sorting the highest element, or the highest element bubbles out to the sorted position in the array. So that's why it is called as bubble sort. Now once I have scanned and one element, that is 4, I have sorted and placed it in the last position of the array. So now I'll start the comparison, or start the scanning from the left side of the array. So now the first element is now 3. So 3 and 1 I'll compare. Now again 3 is greater than 1. So I'll swap 1 and 3. Now I'll compare 3 with the adjacent element 2. Since 3 is greater than 2, so I'll swap 3 and 2. Now I have placed the second largest element 3 in the last but one position in the array. So now I have to compare. So now two more elements are remaining. I'll have to again scan the array to sort them in ascending order. Now 1 and 2 I will compare. Since 1 is less than 2 and they are in ascending order, so I need not swap them. Now the entire array is sorted in ascending order. 1, 2, 3, 4. So here 4 elements are there. So 3 times I'll have to scan the array, and at each time I'll have to compare the adjacent elements. If they are not in sorted order, then I'll swap them to make them in, or to bring them to sorted format. If they are in increasing order, that is in ascending order, then I need not swap them. So now we will see the program. So hash include stdio.h, that is for standard input output every functions. Then void main marks the beginning of the main function of the program. Now I and j are the two integer variables I have declared here to access the array. A is the array I have declared here, and the size is 10. It can hold up to maximum 10 elements. I have made use of another variable temp here, temporary variable, to swap the elements. I need a temporary variable. For that purpose I am using the variable temp. Now next, enter the array limit, that is the number of elements to be inserted in the array, and that limit, whatever user specifies, will be stored in the variable n. Then after that, enter each element of the array, store it in the array a of I. That a of I is used for access the array and store the elements in the array. For example, here I have taken n as 3, so I can run from 0, 1, 2. So the values I have given here is 4, 1 and 2. First value, that is a of 0 is 4, a of 1 the value is 1, a of 2 the value is 2. So since we will be sorting the array, that is the same array variable whatever we have declared, the same array we are going to sort it. That is why before sorting itself, we will print the actual content of the array. So printf the array before sorting, again I equal to 0, I is less than n, I plus plus. So printf percentage t slash t. This is because I want to display the contents of the array with one tab space. So for I equal to 0, 0 is less than n is 3, so 0 is less than 3. So condition is true, so the control will come inside. Printf percentage d slash t. So a of 0, the value is 4, so 4 will be printed. Then again I plus plus, I will be incremented by 1. So I becomes now 1. 1 is less than 3, condition is true, so control will come inside the for loop. Percentage d, a of 1, the value is 1. I give slash t, so one tab space will be left and value 1 will be printed. Now I is 2, 2 is less than 3, condition is true, so the control will come inside the printf. Now a of I is a of 2, the value stored is 2, 2 will be printed, I will be incremented by 1, I becomes 3, so 3 is less than 3, the condition is false, so the control will come outside the for loop. Like this, the contents of the array, the original contents of the array will be printed. So now we have entered the array elements and stored the array elements in array A. The elements are 4, 1 and 2. Now the sorting starts. So the outer for loop here, for I equal to 0, I is less than and I plus plus. This is to count the number of times we are supposed to scan the array. As we have seen in the previous example, there 4 elements I had taken. So I have to scan the array 3 times. So 1 less than the number of elements. So here that's why I have given I equal to 0, I is less than n. Since in this example number of elements are 3, so 0, 1 and 0, 1, that is 2 times I have to scan. So I start from 0, I can go up to 0 and 1. So n is 3 over here. Then the next for loop, J for loop, is used for comparing the adjacent elements and sorting the elements of the array. That is why it goes from 0 to n minus 1 minus I. As and when the first scan is over, last one element will be sorted. So next time when I am scanning A, so remaining elements, only remaining elements I will have to compare. That's why it runs from n minus 1 minus I. So now start the comparisons over here. First iteration, I equal to 0, n I have taken it as 3 over here. So I can go maximum to 0, 1. So 0 is less than 3. Condition is true. So the control will come inside the second for. Now j equal to 0. So j is less than n minus 1 minus I. So n is 3. 3 minus 1, that is 2. 2 minus the 0, so that is 2. So 0 is less than 2, so the condition is true. So control will come inside the for loop. Now I am checking if a of j is greater than a of j plus 1. Comparing the adjacent elements. A of j is a of 0, a of j plus 1, that will be 0 plus 1, that is a of 1. So I am comparing a of 0, the element is 4, and a of 1, the element is 1. A of j, that is 4, is greater than 1. So the 4 is greater than 1, the condition is true. Since 4 is greater than 1, now I have to swap them. So temp equal to a of j. So a of j, the value is 4, 4 will be moved to temp. Now a of j is equal to a of j plus 1, that is a of 1. A of 1, the value stored is 1. So 1 will be moved to A of j. 1 will be moved to A of j, then temp A of j plus 1 equal to temp. So 4 will be moved here. So 1 and 4 are sorted. Now the counter will come back to the for loop. J for loop. J is incremented by 1. J was 0. J is incremented by 1. J becomes 1 now. So the condition is checked here again. 1 is less than 2. So the condition is true. So the control will come inside. Now A of j is greater than A of j plus 1. A of j is A of 1 is greater than A of j plus 1, 1 plus 1, 2, A of 2. So A of 1, the second iteration you can see here, A of 1, the value is 4. A of j plus 1, that is A of 2, the value is 2. 4 and 2 are compared. 4 is greater than 2. The condition is true. So again we are swapping here. So 4 is put into temp. Then whatever was there in j plus 1 to A of j position. So 2 comes here. Then from temp, whatever value is stored, that is 4, is moved to j plus 1 position. So now 2 and 4 are swapped. So now the control again goes back here. J is incrementing by 1. J becomes 2 now. So 2 is less than 2. The condition becomes false. So that is now 1, 2 and 4. So now the largest element 4 is placed in the last position of the array. So this condition becomes false. So control will directly come out and go to the outer for loop. Now I will be incremented by 1. I was 0. I becomes 1 now. So 1 is less than 3. Condition is true. So control will come back inside now. For j equal to 0, j is instead 0 now. 0 is less than n minus 1 minus I. N is 3. 3 minus 1 is 2. 2 minus I value is 1 now. 2 minus 1 is 1. So 0 is less than 1. Condition is true. So control will come inside here. Now if A of j is greater than A of j plus 1. A of j is A of 0 greater than A of j plus 1 is 1. So A of 0, now the value what we have at A of 0 is 1 and A of j plus 1 is 1. So A of 1 the value is 2. 1 and 2 are compared. So 1 is greater than 2. The condition here 1 is greater than 2. Since the condition becomes false, since 1 is not greater than 2, so control will directly come here. J is incremented by 1. J was 0. J is incremented by 1. So 1 is less than 1. The condition becomes false. So it will come outside, go to the outer for loop. Now I is incremented by 1. I was 1. I becomes 2 now. So 2 is less than 3. So again condition is true. So control will come back inside here. Now j equal to 0 and n minus 1 minus I. N is 3. 3 minus 1 is 2 minus I is 2 now. 2 minus 2 is 0. So 0 is less than 0. Condition is false. So control will directly come outside here. I is incremented by 1. I was 2 minus incremented to be 3 now. So 3 is less than n. N is 3. So 3 is less than 3. Condition is false. So directly control will come outside the for loop and it will execute whatever instruction given next to this curly braces. This indicates the end of the outer for loop. Since all the elements of the array are sorted now we have to display the contents of the array. So now we have sorted the array. Now we have to display the sorted array. So printf, we enter the printf the array elements after sorting I given slash n so that the cursor will go to the next line. Now for I equal to 0, I is less than n, I plus plus. So I can run from 0, 1, 2. So printf percentage the slash t I have given. So a of 0, a of 1, a of 2. The contents are 1, 4 and 2 will be displayed. This is the closing of the main function. You can check the output over here. Execute the program and then check the output. Next we will see the selection sort algorithm. So selection sort algorithm also sorts the array elements in ascending order. Now here we scan the entire array from left to right and we go on comparing the adjacent elements and we sort the array elements in ascending order. In bubble sort, at the end of each scan, the largest element bubbles out and is positioned in the last position of the array. That's why it's called bubble sort. In case of selection sort, at the end of the each scan, the lowest element or the smallest element is placed in the first position of the array. After the second scan, the second smallest element is positioned in the second position of the sorted array. So, and also in case of bubble sort, we compare the adjacent elements and if they are out of order, then we swap it. Here we scan the array and we find the minimum element or the lowest element and then swap the elements. So we'll see one example here. So 4, 3, 1, 2 are the contents of the array. So now I assign or I assume that the first element itself is the minimum element and then I compare it with the adjacent element. Now since 4 is greater than 3, so 3 is less than 4, so now I will assign 3 as the new minimum element and then I continue the comparison. Now 3 I will compare it with 1. Since 1 is less than 3, so I found a new minimum element. So 1 is now the new minimum element and compare it with 2, the next element in the array. So since 1 is less than 2, so my minimum element is 1 itself and I have reached the end of the array. Now I will swap it and move it to the first position in the array. So I will now swap 1 and 4 and the smallest element 1 is now at the sorted position, that is at the first position in the sorted array. Now I'll start the scanning starting from the second element of the array. Since now one element is already sorted, so I'll start with the second element. Now again 3 and 4 I'll compare. Since 3 is less than 4, so 3 itself is the new minimum element. So now 3 and next element, that is the last element of the array, I will compare. So 3 and 2 I will compare. Since 3 is greater than 2, so the new minimum element is 2. So now I will swap 2 and 3. So 2 moves to the second position in the array. Now remaining elements I will have to sort. So again I will scan the array. Now I will compare 4 and 3, that is the remaining elements. Since 4 is greater than 3, so the new minimum element is 3 now. Now I will swap 3 and 4. So end of the third iteration, 3 and 4 is sorted. So now the entire array 1, 2, 3, 4, this is the array is ascending order. Note that comparison is same like the bubble sort, but swapping takes place at the end of the scan or at the end of each iteration. I'll just scan the array, compare the adjacent elements and find the new minimum element. At the end of the iteration, the new minimum element whichever is there, I'll sort it and swap it and place it in the appropriate position in the sorted array. Now we see the program here again. A and J for accessing the array. N is to specify the limit of the array. Then A is the array I have declared over here. Again 10 I have given, so maximum 10 elements I can store in the array. Then temp is used for swapping purpose. Then one additional variable minimum here used to indicate the minimum element. So enter the array limit. Again I have taken array limit as 3. Then array elements I have inserted is 4, 1 and 2. Now before sorting, I'll just display the contents of the array here, making use of this particular for loop. Now we'll see the sorting here. So for I equal to 0, I is less than n minus 1, I plus plus. So now here outside for loop here specifies the number of times to scan the array. Now 0 to n minus 1. So that means here now n I have taken it as 3. So I can run from 0, 1, n minus 1 becomes 3 minus 1, that is 2. So I can run from 0 and 1. So that is the limit we have given over here. Next, I have given minimum equal to I. Now we'll see the iterations here by taking the example. That is, now the example here 4, 1, 2 are the contents of the array. So now for I equal to 0, I is less than n minus 1. N minus 1 is 3 minus 1, that is 2. So 0 is less than 2, condition is true. So control will come inside. Now minimum equal to I, that is the first element of the array. I will initialize it as, I will take it as minimum element. So minimum equal to I is 0, so minimum equal to 0. Now for j equal to I plus 1, now I will compare this minimum element with the next element, adjacent element. So j is equal to I plus 1, because after each scan, first, for example, after first scan, first element is sorted. So then I have to start with the second element. Second element will be assigned as minimum element. I should compare it with the adjacent element, that is the third element. So that is why I have made it as I plus 1. So j equal to I plus 1. So 0 plus 1 is 1. So j is equal to 1 here. J is less than n. N is 3. So 1 is less than 3, condition is true. So control will come inside. Now if a of j is less than a of minimum, a of j is a of 0 is less than a of minimum. A of minimum is a of 0. So a of j is 1. So a of minimum is 0. So a of 1 is compared with the a of 0. So a of 0 the value is 4. A of 1 the value is 1. So now a of j is 1. 1 is less than 4. The condition is 1 is less than 4 is checked. Since 1 is less than 4, the condition is true. So now the new minimum element will be 1. So now minimum should point to this location. So that is why minimum equal to j. So minimum, now minimum value becomes 1. So and minimum points to the location 1. Now again control will come back here. J is incremented by 1. J was 1 is incremented, so J becomes 2. So 2 is less than 3. Condition is true. So again control comes inside the for loop. Now this condition A of J is less than A of minimum. Now A of J value is A of J value, new value of J is now 2. So a of 2 is less than a of minimum. Minimum value is now 1. Minimum is pointing here. So now a of 1. So a of j is a of 2. A of minimum is a of 1. So a of 2 the value is 2. A of minimum the value is 1. So now 2 is less than 1. The condition is check this, 2 is less than 1. Since the condition is false, so the control will again move back here. This if part is not executed, so control will come back here. J is incremented by 1. J becomes now, J was 2, J becomes now 3. So 3 is less than 3. 3 is less than 3, condition is false. So control will go outside this for loop, that is will directly come to this part. Now if minimum is not equal to I, now I am checking whether the first initially I have mentioned the value, minimum value assigned it to I. So I am checking whether the first value itself was minimum or not. Now I have found a new minimum value. So now minimum is not equal to I. Minimum is pointing here. The minimum value of minimum is 1. So I value is 0. So 1 is not equal to 0. Condition is true. So now I have to swap this element 1 with the first element. So temp equal to a of I is a of 0, the value is 4, is moved to temp. Now a of I equal to a of I equal to a of minimum. So a of 0 equal to a of 1. A of 0 the notation, the value to be moved is a of minimum, that is a of 1, the value is 1. So 1 is moved to this position, and value 4 is in temp, which is moved to A of minimum position, that is A of 1. So 1 and 4 are swapped. Now this ordered it is 1, 4, 2. Now again control will now come back here. So I is incremented by 1. So now first iteration is over. Now I is incremented by 1. I was 0, I becomes 1 now. 1 is less than n minus 1. N minus 1 is 3 minus 1, 2. So 1 is less than 2, condition is true. Now minimum equal to I. So minimum equal to 1. So now minimum is pointing here at location 1. So now for j equal to I plus 1. So j equal to I plus 1. So I is 1. So 1 plus 1, 2. So j will be pointing here. So j equal to 2. So 2 is less than n is 3. So 2 is less than 3 is true. So condition is true. So control will come inside the for loop. A of j is less than A of minimum. A of j is A of 2 less than A of minimum. A of minimum value now is 1. So A of 1. So A of j is, the value is 2. A of minimum, the value is 4. So 4 and 2 are compared. So 2 is less than 4. The condition is checked. 2 is less than 4. The condition is true. So minimum equal to j. So now minimum equal to j. So this is the new minimum value. So minimum will point here. So minimum equal to 2. So minimum will be pointing here now. Now control will come back here. J is incremented by 1. J was 2. J becomes 3. Now 3 is less than 3. Condition is false. So it will directly come outside the for loop, that is here, outside the inner for loop. So now minimum is not equal to I. So minimum is not equal to I, that is minimum is 2 now. I value is 1 now. So 2 is not equal to 1. Condition is true. So temp equal to A of I. A of I is A of 1, the value stored is 4, that is moved to temp. And then A of I, that is A of 1 equal to A of minimum. A of minimum is A of 2, the value stored is 2 here. 2 is moved to A of I position, that is second position. Then whatever value was there in temp will be moved to this position where minimum is pointing, that is minimum is A of 2 here. So temp we have moved the value 4. So 2 and 4 are swapped now. So now control will come back here. I is incremented by 1. I was 1. I becomes 2 now. 2 is less than n minus 1 is 3. So 2 is less than 2. Condition is false. So now the array is already sorted. So condition becomes false. So the control will directly come outside the outer for loop and will execute the next instruction. Now the array is sorted. We have to display the sorted array. So I made use of this for loop to display the sorted array element. I use /t so that one of the array elements after sorting are displayed with a tab space. 1, 2 and 4. If the sorted array will be displayed here. So